In this video, we are going to talk about the end behavior of the polynomial functions. Polynomial functions have a degree n, and depending on the degree of n, the function behaves at the extreme ends. So the end behavior of a function describes how the function behaves as it moves infinitely to the left and right. In other words, end behavior is what happens to the values of y. We are looking at the y values as x increases or decreases without bound. Okay, so without bound means it goes towards infinity. There are two ends of end behavior of the polynomial. So let's discuss the left end. Left end means x value decreases without bound, means x goes to negative infinity. Increases without bound means x goes to infinity. So this is a right hand, this is a left hand. Now talking about limit notation. So this is the first time you are using limit notation, or you may have learned this in a pre-calculus. I'm not pre-calculus, but in other course. So what is a limit notation is how do we write? So we do not write the whole word limit. We just use the three letters lim. Then underneath we write it x arrow number, and then here is the f of x or the y. So we are just focusing on what's happening at the extreme end, and then we will talk about the limit notation. So clearly describe the end behavior of the following polynomials verbally and using limit notation. So let's talk about verbally. Left end behavior. So what is left end behavior means x goes to negative infinity, where the y is going. X goes to negative infinity, y is going to infinity. You may recall this is how you used in algebra 2. Algebra 2 method is you were writing like this: x goes to negative infinity, y goes to infinity. Now, what is left-hand behavior with a limit statement? What is a limit statement? The same answer, you have to write it fancy way. So let's practice how to write. So first is lim, lim, then x arrow negative infinity. Then comes the function f of x. Normally we write f of x, or you can write y. So lim x goes to negative infinity f of x. Now we know that it never equal to infinity, but we still have to write is equal to infinity. So this is pre-calc method. So let's understand one more time. Algebra 2, you write the arrows: x goes to infinity, negative, y goes to infinity. In pre-calc, using limit statement, we write lim underneath x arrow negative infinity, f of x is a y which is going to infinity. Now right hand behavior. So here x goes to infinity, y is going to negative infinity. So one more time, let's write. How do we write in algebra 2? Algebra 2 way is x goes to infinity, y goes to infinity. Again, this is algebra 2 method. How do we write in pre-calculus? Lim x arrow infinity, y is f of x equal to infinity. Now we know that so many of you will argue again that it never equal to, but we are writing the statement, limit statement, which is, my bad, it's negative infinity. So x goes to infinity, y goes to negative infinity. This is algebra 2 method. This is pre-calc method. So let's practice one more example here. You can clearly see that x goes to infinity, y goes to infinity. X goes to negative infinity, y also goes to infinity. So what's algebra 2 and what's a pre-calc method? So algebra 2 is x goes to negative. Let's rewrite again. I'm sorry. Okay, so x goes to negative infinity, y goes to infinity. Limit statement is lim x arrow negative infinity. f of x is equal to infinity. Algebra 2, pre-calc. Later on, you don't have to write algebra 2, you have to write pre-calc. So let's write straight pre-calculus way. LIM x goes to infinity, f of x. And you can see from the graph, it is going positive infinity. So verbally means x goes to infinity, y is also going to infinity. So clearly, both places you are going up. The y values is going up. So this was easy from the graph. Let's see how do we do other examples. Okay, so this is very interesting. You have to sketch a polynomial with the following end behavior. And you have to be creative, and anything could happen in the middle. So let's interpret this piece. X goes to negative infinity, limit x goes to negative infinity, y value goes down. So I have to go somewhere down. X goes to positive infinity, graph is also going down. Now what would you show in the middle? Anything, be creative. I would go up and then I would go down and then I would come down, anything. Whichever way you understand, but this is the end behavior. So let's try one more. X goes to negative infinity, graph goes negative infinity, which means x negative, y negative, third quadrant. X goes to infinity, y goes to infinity. So possible polynomial function. Anything you want. Well, I'm going to go up and then I'm going to go down and then I'm going to go up and then I can go this way. Anything, whatever you want, as long as it's a function. It should pass the vertical line test. It should be a function. Okay, so that was easy. Okay, so polynomial end behavior. For polynomial equations, it is easiest to find end behavior of the right side first. Right side first, because many times we know that the x goes to infinity, function is going where? So the right side, the function goes to infinity if the leading coefficient is positive. For example, y is equal to x square. It goes up, right? It goes up. If it goes to negative infinity, if leading coefficient is negative. For example, y equal to negative 2x square. So you can see it goes down. I hope you understand that piece. Leading coefficient. Okay, so then what's happening to the left side? Goes in the opposite direction. Opposite directions as the right if degree is odd. Okay, this is very important. You know that x cube, x fifth are always opposite directions. And it goes in the same directions. If the degree is even, you should know x squared, x to 4, x to the 6. Either they both go up or they both go down. So once you have this basic understanding, it is so much easier again to find the end behavior from the equation. So fifth degree, positive. So visualize this is my graph look like. So where does this left end goes to negative infinity, right end goes to positive infinity. So let's write the limit statement. Lim x goes to negative infinity, f of x goes to negative infinity. Lim x arrow positive, f of x is positive. Understand again, fifth degree, opposite direction. Coefficient positive, that means positive, other side opposite. So even, everybody should know. Fourth degree, both goes in the same direction. So left hand and right hand, they both are going up. How do we write? So lim x arrow negative, g goes up. Lim x arrow positive infinity, g is also going up. Okay, so now this is very interesting. Negative 2, the leading coefficient is negative. So x to the 6 is this. But the leading coefficient negative, which means your graph is like this. So what will be the end behavior is both ends, it goes negative infinity. So one more time, lim x arrow negative infinity, y goes to negative infinity. Lim x arrow positive infinity, y is also going to negative infinity. So from the equations, you just have to visualize the graph and you can identify where it's going. Let's practice some more. 3 minus x to the fifth. So normally x to the fifth is this. Negative means going down. This is x to the fifth. Negative means it goes backward. This is negative x to the fifth. So left hand goes to positive, right hand goes to negative. Lim x arrow negative infinity, h of x is going to up now. And lim x goes to positive infinity, h of x goes to negative infinity. So the most important part is again to visualize the graph. Visualize the graph. This is x to the fifth. Negative means it's flipped. This is a tricky question. Look for the highest degree. The highest degree is x to the negative fifth, x to the fifth, and the leading term is negative. So if you want, you must rewrite this as negative x to the fifth plus 8x squared plus 4. And this is the leading term, is the only one who will decide the end behavior, which is very similar to this. So I'm not going to write. It's going to infinity and negative infinity, which is same answer. Okay, so now let's check about here. Something is missing here. This is x actually. So this is in factored form. 2x, x minus 1, 6 minus x. So you can say that you multiply this, you get 2x squared. Then you multiply this with a negative x. Multiply this with the negative x will give you negative 2x to the third. You are not interested into the tail. You are only interested into the leading term. Leading term 2x times x, x squared multiplied by x negative. So now remember x cube is normally x cube goes like this. Negative x cube is this, which means left hand is up, negative, right hand is negative. So practice one more time. Lim x arrow negative infinity, m of x is infinity. Lim x arrow infinity, m of x goes to negative infinity. So I hope you got this left, right, left, right. Now let's try to write without any left and right. Straight directly the limit statement. So let's get the format ready first of all. Lim x negative infinity f of x. lim positive infinity f of x. Okay, so now let's visualize even degree. So x to the 4 is this, negative sign is this, which means both ends are negative infinity. Let's try one more. Cube. Cubic functions are this. So lim x arrow negative infinity g of x is going down. Lim x goes to positive infinity, g of x goes up. Okay, so for writing is easy, lim x infinity, negative infinity, but you must understand the meaning. The meaning is x increases without bound. Know the vocabulary word. What this means, x decreases without bound. So the meaning, the vocabulary words you have to understand, and you have to know the statement. Goes to infinity, increases, negative infinity, decreases, without bound means infinite. Okay, so now we are almost there. We are not going to use calculator without using a calculator. It is expected that you know the basic functions, how they look like, and behavior of these functions. Okay, so this is a very easy peasy parabola. I believe you can do yourself. I want to help you with this one. Okay, so g of x is a rational function. Anytime x goes to extreme ends, these numbers are not important. So you only look at leading terms are 2x over x. We don't care what is 2x over x. This is 2, which means this rational function has horizontal asymptote y equal to 2, which means end behavior is lim x goes to negative infinity, g of x is a 2, and lim x goes to infinity, g of x is also 2. One more time, when x goes to infinity, all this tail is not important. We are only looking at the leading terms. So if I apply that same strategy here, there is a negative sign also here. So h of x, tan is not going to make a big difference. But let's keep it. Just rewriting this. So h of x is x goes to infinity, which means lim x goes to negative infinity, lim x goes to infinity. Okay, so this is a little bit different one. You can see that when x goes to infinity, this is a very, very big number, and we can call this as bottom heavy also. And bottom heavy means 1 over infinity, very, very big number is always 0. So this answer is a 0, and the negative number square is also positive, and that's also 0. We are going to discuss this later when we talk about the rational functions, but I would like to make a connection here because you have already learned the function 1 over x. So what is 1 over x graph look like? You have to make a connection. 1 over x is, you have learned this in algebra 2, which is a hyperbola, and there is a horizontal asymptote and vertical asymptote. Now you are squaring. So when am I squaring? So that means, and what that means is these are still there, but this number goes up. And we still have horizontal asymptote at 0. Now, if you flip the negative sign, that means the graph is reflected over the x-axis, and still have a horizontal asymptote, still have a vertical asymptote. The graph would look like this. So you can confirm that x goes to negative infinity is a 0, x goes to infinity is a 0, and we call this as a bottom heavy function because variable is in the denominator and x goes to infinity, it's always becomes 0. So I'm wrapping up this end behavior using limit statement. Make sure you should be able to do from the graph and from the equations.